Okay, so I know when you guys think back to elementary school and you think about all those wonderful memories you had dividing two numbers, including dividing using long division, you will have some great memories to build in this class on dividing polynomials. So, what we're going to be doing, we're going to be dividing polynomials instead of numbers, and we're going to be incorporating the skills that you guys learned about long division, but with polynomial long division. It's going to be awesome. Okay, guys, so in class, we did kind of a basic long division problem, and the reason why I had you guys do this was to compare it to see how polynomial long division is going to be. Because guess what, you guys? The process is the same exact thing. The only thing that's different is polynomials, first of all, have variables. Secondly, we have more terms to deal with polynomials. But I'm telling you guys, the process is the exact same. So, if you loved long division in elementary school, guess what? You're going to love polynomial long division. So, let's talk about the division algorithm, which states how we divide using long division and also how we are going to write our answer. So I have all these weird symbols and I'm going to explain it. So we have d of x, which is the divisor. That is the number that is dividing into the original polynomial, which the original polynomial is called the dividend. So again, we divide the dividend by the divisor. P of x is our dividend, that's how we denote it, and d of x is the divisor. Okay, and again, the dividend is divided by the divisor, or the divisor is divided into the dividend, however you want to look at it. Okay, the next thing we're going to talk about is the quotient, which that is the answer that you get on top of the division bar. So if you guys think back to our original problem, we have the divisor, the thing dividing into the dividend, which is being divided into, and q of x is the thing we write on top. That is our answer. And finally, this thing at the bottom, r of x, is our remainder, which what is left over. So again, r of x is what is left over. Okay, and if you get a remainder of 0 at the bottom, that means that you do not have a remainder, which is kind of cool, which that will kind of come into play when we start working example problems, so get excited. Okay, so again, we have the divisor. The dividend is p of x, q of x is our quotient, and r of x is the remainder. Now, this is what it looks like when we solve using long division, but this is how we're going to write our answer. So let's talk about that. So after we divide the dividend by the divisor, we're going to write our answer, which is the quotient, but then we're going to add the remainder and divide it by the divisor. So every single time, whatever's left over, you divide by the divisor. And if that does not make any sense, you guys, I promise you it will make more sense when we solve some awesome example problems. So why don't we dive into some example problems? So example 1 and 2, I will be showing you how we do long division when we have polynomials, which is going to be epic. So get excited, go ahead and pause the video and watch example problems 1 and 2. Hold your horses, these are some funsies, we'll do them later. Alright, now, synthetic division. I know you guys had so much fun doing long division, but there's also a different technique for polynomial division called synthetic division. Okay, so synthetic division, no matter which one you choose, long division or synthetic, you get the same answer each time. So after I teach you synthetic division, you kind of get to pick which technique you prefer, and that's the one you can kind of stick to. Okay, so synthetic division, it's a different way to divide. Okay, and you get the same answer as long division. Now, some bonuses using synthetic division. It is a much faster process than long division. Okay, and most of my students usually think the process of using synthetic division is actually easier than long division. So usually, synthetic division is much more popular than long division. But again, after I teach you synthetic division, if you're like, Miss Long, this crazy new division thing, I don't like it, well, guess what? You don't ever have to use it again. You can use long division. Now, synthetic division is limited, you guys. Okay, we can only use synthetic division if the highest exponent in the divisor, so like the x minus 2 here, or the x plus 3, the highest exponent you can have in synthetic division in the divisor is to the first power. Okay, if this was like x squared minus 2 or x squared plus 3 or x to the fourth plus 3, we can no longer use synthetic division. So, it is limited. Now in this class, we will only be doing stuff to the first power, so you can always use synthetic. But if you take upper level math classes, they will not always be to the first power, which means you're going to have to use long division. So it is helpful to know long division. It's not a waste of your time. Alright guys, well I know you're dying to learn about synthetic division, so go ahead and pause the video and watch example problems 3 and 4. Here are some funsies which we will be doing later. Alright guys, now we're still talking about synthetic division, but the leading coefficient of the divisor is no longer 1. If you see, there's a 2 in front of the b here and a 3 in front of the z here. Okay, so ignore this 6. I don't know what that is. But anyways, before, when we were solving, the leading coefficient of our divisor was 1. Like the number in front of x right here is a 1, and the number in front of this x was a 1. Same with all the example problems. Okay, the number in front of this x was a 1, as well as this x was a 1. So, we can only do synthetic division, sorry guys, we can only do synthetic division if the leading coefficient of our divisor is a 1, which if you see here it's a 2, so that's a problem. But I'm going to teach you a way to get around it. So, go ahead and pause the video and figure out how we can still use synthetic division when the leading coefficient of the divisor is not 1. Alright, so in class we did a nifty activity where you guys found another way to find the remainder other than doing long division or synthetic division. Okay, this is called the remainder theorem, or sometimes, if you look down here, it's called synthetic substitution. So, what's going to happen? If you take p of x, which is the dividend, okay, and if you're dividing the dividend by x minus r, if you substitute in the opposite of this value right here. So if I substitute in positive r, not negative r, back into the dividend, the answer that you get is actually going to be the remainder. Isn't that cool? Okay, so there are more than one way to find the remainder. You can either do long division or synthetic and get the remainder, or you can substitute in the opposite value of the divisor into the dividend, and bam, you are going to get the remainder. Okay, so if that didn't make sense, it's okay. I have some wonderful example problems to show you what I'm talking about. So in example 6, this is example 6 right here, the 6, the period is right here, kind of morphed into the parenthesis, I apologize. But this is example 6, 6 has nothing to do with the problem. But anyway, so for example 6, we will be finding the remainder through polynomial division, which that means either synthetic or long division, and we will also be finding it through synthetic substitution, which is applying the remainder theorem. So, go ahead and pause the video and find the remainder using 2 different methods. Holy hot dog, you guys. And that's it for dividing polynomials.